Well, good morning, good afternoon, or good evening, depending on where you are in this world. Welcome to today's DevOps.com webinar, From Monolith to Microservices and Beyond, featuring Electric Cloud and Trace 3. My name is Charlene O'Hanlon. I'm the moderator for today's event, and we have some really great information on tap for you. But first, we have a couple of housekeeping items that we need to go over. First of all, you will receive a link about 24 hours after the webinar has happened that will provide an on-demand access to the webinar along with the slides. So if you miss all or part of today's webinar, you will receive that link and you can go over and listen to it again tomorrow. We also will be taking questions throughout the webinar today. We'll be asking the questions at the end. So at any time during the webinar, please feel free to submit your questions and we'll get to them as soon as we can. Now I would like to go ahead and introduce today's presenters. First off, we have Marc Hornbeek, who's Principal Consultant at DevOps. Then we have Anders Wallgren, who's CTO of Electric Cloud. And then we have Sam Fell, who's the moderator, and he's also with Electric Cloud. Welcome, gentlemen. It's great to have you guys here.
Thank you.
Thank you. Good to be online.
Thank you.
Great. Well, looking at the next slide here, I believe we are actually going to kick off with a polling question. So we do have a poll question coming up for you right now. It's right on the screen. The question is, where are you in your journey to microservices? So this is the time when you want to go ahead and make your selection. We have 4 answers to choose from. We haven't started yet, just getting started. We have multiple teams releasing microservices in production, and we are fully microservices-ized. Is that even a word?
It is now.
It is now, yeah. Okay, great. Well, we'll give the audience about 10 more seconds or so to go ahead and get their answers in, and then we'll take a look at the polling results. And then I believe we have one other polling question after that before we kick off the conversation. Okay, we've closed the poll, and looks like we have a lot of, most of you who are actually just getting started, so the majority of you. And then a fair amount of you who haven't actually started yet. So hopefully this presentation will give you plenty of information to help you along that journey. Okay, let's go ahead and, while we're at it, do our second poll, and then we'll go ahead and get to the conversation. Second question is, how are you primarily managing microservices release? We have 5 answers for you. Go ahead and select one of them. We have microservices-specific tooling. We have scripts. We have ARA tools. We have homegrown solutions, or we have open source tools. And you can choose one of those. We'll give the audience about, another 10-15 seconds or so, and then we'll go ahead and take a look at the polling results. And then I will be quiet and let you guys have your conversation. Also, just so you know, we are going to be sharing the poll results on Twitter. So if you missed them here, you can look on Twitter. Okay, here are the answers. It looks like 19, or actually, I'm sorry, the majority is 45% using open source. So that's really kind of an interesting answer there. With that, I would like to go ahead and turn it over to Anders now, I believe, and we'll let you guys go and have your conversation. Thanks.
Great, thank you very much, Arlene. Interesting kind of answers to those questions there. I think in some ways, we've asked these types of questions in our webinars for years and years and years. We started out kind of asking about, where are you in your agile journey, your continuous delivery journey, those kinds of things. And it's always been really interesting over the years, as we ask the same question over and over, seeing how it, kind of takes shape as people adopt more and more. So I'm actually a little bit encouraged to see that so many of us are, are working on this stuff, because it's fun and it's cool and it helps. So enough about that. So I'm gonna talk. I have a few slides I'm going to share with you guys, talking about this. In particular, talk a little bit about what microservices, are and what's cool about them. A little bit, throw a little bit of shade at monolithic apps, but there are some benefits of monolithic apps too. It's, it's not a complete slam dunk. Talk a little bit about the challenges of microservices and get into a little bit of the best practices. And then, Mark will take us through his slides, and then we'll have some time for discussion and Q&A at the end. So what are microservices? It's really, the sort of the formal definition is a pattern for building distributed systems, right? So instead of building a one process that does everything and then having to replicate that process all over the place, you decompose your complex applications into individual services running on individual machines, typically, or at least individual containers. And there's a bunch of benefits for this. You can deploy them, you can develop and deploy them independently, so you get some nice decoupling between your different teams as they're working on their problems. And really, the point of microservices here is get a service that focuses on doing one thing well, and sort of make that the thing that it works on. And a quote here from Robert Martin, gather together those things that change for the same reason and separate those things that change for different reasons. And what you often find with microservices is people will, you'll write a microservice to do a certain thing. You may not touch that thing for a very long time, which is kind of a good thing, right? You're off touching new things and working on those things. So other cool things about microservices are, it's fundamentally a way to kind of divide and conquer on the problem and allow people to kind of get out of each other's way. Complex distributed applications are, they're complex. That kind of goes without saying, even though I just said it. And there's a lot of moving parts. You've got to do authentication. You might have to do authorization. You might have, shopping parts that you have to deal with, catalogs that you have to deal with, blogs or forums, or there are just a bazillion different things that we have to do as we write our applications. And with microservices, one of the cool things about that is we get loose coupling between these services. And a nice thing about that is you can choose the tooling that's appropriate for the particular problem you're trying to solve with microservice X. And so you could be, maybe you're using Java for some of the heavy lifting, and maybe you're using Python for other stuff, and Node.js for other things. And really, there is no, there's no mandate across a set of microservices, but they use the same technologies. They're going to communicate with each other over the wire, over the network, and talk to each other that way. So they don't have to use, it doesn't have to all be, C or C++, or all Java, or all Perl or Python, or what have you. And that has the benefit, too, of making it easier to adopt new technologies, because you don't have to go rewrite the whole damn monolith just in order to use some cool new library or cool new framework or cool new language that you think will help you solve a particular problem better than you did before. And I think also, kind of last on this slide, smaller, more autonomous teams are more productive, right? You get better utilization out of those kinds of teams, and also better resource utilization when you go deploy these things. One of the nice things about microservices is they're independently deployed. So I can have different life cycles for different microservices. I can have independent teams on completely independent schedules, rolling their functionality forward as they need to. And because we're loosely coupled here, I can, as long as I maintain backwards and forwards compatibility or maintain, multiple versions of the same service, I can make lots of changes to my services and enhance them, and be, and even be servicing multiple applications with my service, and be able to rev my service to better support application A without, removing support for application B. So it makes everything nice and loosely coupled, and makes it, much easier for us to develop software and get it out there more quickly. Now, so we kind of set up monolithic apps as the bad guy here, right? But let's cover a little bit about sort of the good, the bad, and the ugly on monolithic apps. They're not all bad. I'll kind of go through this in the blues are the good, and the greens are the bad. And we may have made a sort of a logistical mistake here for people who are a little bit colorblind, but hopefully it's easy to sort of figure out what's what here. Monolithic apps are easier to test generally, right? I mean, if you think about this, if I'm comparing a monolith, say a large WAR file, that has everything in it that I need for my application, that's typically going to be a little bit easier to deploy into my local JBoss instance or my local whatever instance on my laptop, as opposed to my 52 microservices, where if I needed to stand them all up and do a system test or some sort of integration test, I need to be able to, as a developer, stand up those 52 microservices and do that. Now, of course, when you're testing microservices, you're going to do things a little bit differently and try to avoid the scenario where you have to have all of them running at the same time, and do most of your testing, as is recommended for most things. Do most of your testing as unit tests, do some testing as integration tests, do as little system testing as you need to. The monoliths, can also be easier to develop, right? I mean, you may have a single framework that you're using. You may have a single, kind of language, and everybody lives in that, and so everybody shares the knowledge. You don't necessarily have, a bunch of different teams using completely different technologies, or maybe all of a sudden the skill set becomes a little bit less fungible. That's not really that big a deal, but it bears pointing out. Monoliths can definitely be easier to deploy. They're not always easier to deploy. But a problem with that is you can't deploy anything until you deploy everything, right? Your monolith is this big, huge chunk of software, and if I need to fix a bug, even if it's just a one-liner in the fix, and it affects, one jar file that then gets packaged into my WAR file, I have to redeploy the entire application in order to deploy that patch, and that might be a much heavier lift than, say, replacing a single microservice in the system. With a monolith, typically you're going to have a harder time learning and understanding the code because you have a large code base and a larger code base, and it's probably going to be, over time, unless you're incredibly skilled and incredibly diligent about modularity in your code and packaging of your code, you will sort of, kind of the second law of thermodynamics, will drift towards entropy, more entropy at some point, and then your bits will rot. If I need to understand the functionality of feature X, I first have to find feature X in the code, right? With a microservice, feature X, is probably just, a single standalone microservice, a much smaller chunk of code for me to understand, and I'll probably have an easier time kind of finding and locating it than I will, kind of go in there. But of course, monolith-wise, it's easier to produce the spaghetti code and harder to adopt new technologies. And kind of in the same way that you can't deploy anything until you deploy everything, it's the same with scaling, right? If I have to scale and run multiple instances, horizontal scaling of my monolith application, I have to be able to scale every single module or every single piece of functionality in my application, and that can be difficult, and it may not be necessary, right? You may need to scale only, silly example, but you've got let's say you've got a piece of functionality that serves up an avatar for the user when they go to their settings or profile screen. If I have to scale that up and I have to run multiple instances of my monolith, I'm running multiple instances of that huge monolith, taking up memory, taking up CPU space, all of those things, even though I only needed to scale a tiny little piece of it. If you break that functionality out as a microservice, you can scale that microservice independently of everything else, which is kind of good and how it should be. So I referred earlier to the idea that we can have several smaller teams working on this kind of decomposed microservices problem, and get more work done that way, and be more efficient, and all of these things. And those among us who have read the mythical Man Month from Fred Brooks, very famous book. If you haven't read it, go read it. Very interesting. But one of his points there was basically, look, you can't ship software faster by throwing people at the problem. One of the main reasons being the amount of communication that has to happen between the individuals, increases much more quickly than the rate at which you can increase people. And so you don't necessarily get more done. Kind of in the same way that if it takes 9 months to have a baby, if you get 9 women together, they're not going to have a baby in 1 month. A silly example, kind of trivial, but it kind of gets the point across. So you really can't, in typical fashion, get more work done. So but I'm saying, hey, with microservices, we can have independent teams working on this stuff, cranking out code, not getting each other's way. So, was Fred Brooks wrong? And as I put up here, no, it's still the case, right? But I think it applies largely to if you're talking about a single team, right? Here we're talking about independent teams. Now, clearly, the teams are going to need to communicate with each other. So there is going to be more communication here. But it's the same kind of communication that already had to happen in your monolith, right? You're talking about APIs. You're talking about what piece of code is responsible for what functionality, those kinds of things. So overall, that doesn't change much. So you're still a little bit at danger there of having a lot of communication that has to happen. But once you get down to kind of writing the code and maintaining things and doing doing all the other stuff that you need to do as part of your software pipeline, testing and doing all the QA things you want to do, running security checks, performance, load testing, regression testing, all of those kinds of things, you are much more independent, right? And you're not going to be, you're not going to run into issues like, well, I just checked in something that broke this functionality, and that means now the whole monolith is broken, right? That's going to be a little bit less prevalent in the case where we go off and work independently. So, as we've seen, there's a high correlation here, and that's kind of what the graph here is from the 2015 Puppet Labs report on the state of DevOps, where the high performers in the DevOps arena, there's a high correlation with the number of deployments per day per developer, and we're seeing a correlation also between the number of deployments that we can do and the number of microservices, or the amount of adoption that we have of microservices. So there's absolutely a way to get more productivity out of larger teams, out of more people. You have to be very careful and structure them correctly, and sort of keep in mind that the communication aspect is definitely still there, but it's still a cool thing. So so the question then kind of comes, well, should I use microservices, right? Is this is this something that we should jump all over and throw out all of our code and rewrite everything as microservices? So the answer is kind of maybe, right? There are a lot of things that you have to be or need to be pretty good at in order to have a successful experience with microservices. One of those things is you have to have a pretty good handle on your software pipeline, right? So if you've got really solid continuous integration, you've got automated testing, automated deployment of your monolith, and you're looking to kind of scale the organization, right? Then maybe you should be looking at microservices. You should definitely read and learn about them either way. But if you don't have automated testing, then you have to worry about that first, because testing is going to get a little bit more interesting with microservices, and you've got to become or be very good at automated deployments and monitoring as well to really reap the benefits of microservices. If you're monitoring both in production, and I would argue also during the software pipeline before you get into production, if you're not good at monitoring, then as a favorite tweet of mine once said, we switched to microservices and now every outage is a treasure hunt. If you're not doing good monitoring, when something breaks in your microservice, you got to go find it, and if you've got 1,000 microservices and there's one of them that broke, it may not be apparent right away that that's what's causing the problem, because you might be seeing symptoms downstream from the service that's causing the problem. And so now you got to hunt that down. So you got to get good at automated deployments. You got to get good at automated testing and be pretty good at monitoring to really reap the benefits of this. So, are you ready for microservices? If you're just starting out and you don't have a huge code base right now, then you're kind of in good shape, right? But the recommendation that I have, and that a lot of people in the industry kind of talk about, is if you're starting from scratch, stay monolithic for a while until you understand the problem you're trying to solve a little bit more, so that you understand the data domain that you're working in, and you understand the kind of the functionality and the user stories and all of those things that you're trying to do, because if you immediately sit down and on day one, before you write line one of code, and decompose your problem into what you think it should look like and into its 52 different microservices, you might make a lot of mistakes, and it can be expensive to shift around the boundaries between microservices, right? If I have to move an API from one service to another, that means that everybody who depends on that service now has to also shift their utilization, and either depend on a new service that they didn't depend on before, and code to that, or at least move the invocation to a different service. So until you understand the general shape of what you're trying to do, it's better to stay monolithic until you really start to see the patterns emerge, and you start to see, okay, this thing is completely separate. Let's rip that out and do it. Another thing to talk about is you've got to be good at infrastructure provisioning. Whether that's infrastructure as a service or PaaS or what have you. You're going to be, if you're successful with microservices, you're going to have a ton of them. So you're going to have to be good at provisioning the infrastructure that they run on. And you're also going to have to be good at deploying the applications on top of that infrastructure. And then, as I mentioned before, you've got to get good at monitoring that application once you have it out there, and that's going to be a little bit different than in the monolith. And lastly, and this is kind of a benefit as well as a challenge, is you need to have really good domain and system comprehension, or somebody at least has to have good domain or system comprehension across all the different services and the application problems that you're trying to solve, so that you do these decompositions correctly, and so that your services evolve correctly. And that can seem a little bit daunting, especially for large, complex applications, but it also has benefits, right? Because now you have the kind of the motivation to develop good comprehension, to develop maybe better documentation if that's what it takes, or better ways of documenting your APIs, or those kinds of things. So there are kind of side benefits that come out of that as well. Now, so what's tricky about microservices? Lots. Distributed systems are difficult, right? These are not slam dunk kind of things that that we're working on. In particular, state management is always a challenge. So if you're using RDBMSs and you've got transactions that you're dealing with, and you're doing caching of data and other kind of state management things, that will be challenging to you when you deal with a microservices transition. You have to figure out who's going to manage that data. You want to be careful not to get yourself into scenarios where if you start thinking, oh, I'm going to need to do a multi-phase commit, a two-phase commit here, and I need a transaction coordinator, and all that kind of stuff, you're probably going down the wrong road, right? You better have a really good reason why you're doing those kinds of things. What you want to strive for is independent services that have independent data domains that they manage. That will make your life a lot easier, but that can also be challenging, right? Especially if you're decomposing a monolith. So you need to keep that in terms. And then organizationally, right? You need to sort of worry a little bit about the kind of the cultural and communication aspects of having lots of teams, right? It's great if I have an application and I decide to break it down into 50 microservices. But what if I don't have enough people to have 50 different teams dedicated to that? If I want to have 5 people per team and I don't have 250 engineers, I only have 50. What do I do? Do I have 1 engineer per team, or do I, So you have to figure out, kind of how to allocate people across these things. And do people, work on a service for a while and then they move off and work on another one? And how do you do that? And you want to make sure that you don't kind of silo people into these services, and so that you don't, you kind of lose the ability to have fungible skills and be able to have people hop around between different teams if they want to work on different things, or if you need extra help on another team. And then you also have to kind of keep in mind Conway's law, which is kind of the example I always hear is Conway's law basically says if you're building a compiler and you have 4 different teams building the compiler, you will have a 4-phase or a 4-stage compiler, right? The structure of the code will mirror the structure of the organization. Now, that's kind of what we want in microservices, right? But you have to be a little bit careful and make sure that you don't make any mistakes just because of that. And then you have to, you got to think about, what do we do about our legacy apps, right? Are we going to rewrite them, just let them be? Are we going to kind of come up with a hybrid approach where we start to chip off things from the monolith and turn them into microservices so that we can, kind of evolve and move forward from there? And that is something that you kind of have to worry about. And as I said in the previous slide, good system comprehension is kind of key to get this thing up and running and do that. And you also have to think about, your service might be small, but how large is the deployment footprint? One of the benefits that we're trying to get out of microservices, maybe not the biggest benefit, but one of them is, we can run our services in a smaller footprint because they're smaller. Well, if you've got a WAR file that's hosting your tiny little microservice, and you deploy that thing in a giant J2E container service, running inside of a VM, you've got a pretty big deployment footprint. So you want to think about, what kind of containers am I deploying into? Both containers in the sense of kind of the J2EE containers, JBoss, WebLogic, WebSphere, those kinds of things if you're in the Java ecosystem, but also containers in the sense of Docker and those kinds of things. It's always good to worry about and think about what this will look like. So I'm going to kind of quickly go through some of the best practices that we see people having success with, right? So what makes a good microservice? You absolutely want loose coupling, right? If I make a change to service A, then that shouldn't filter through to require a change in service B. Otherwise, those two services are probably too tightly coupled, or I'm still evolving my APIs, perhaps, would be a charitable way to put it. And you might over time decide that A and B really ought to be one service, or you may decide that this piece of A really ought to be over in B, or maybe should be a separate third service, C. You want to focus on having a small, tightly focused API. You want high cohesion between all the the different services, right? Each service should have a specific responsibility, and if you start to see that sort of blow up a little bit into more general purpose stuff, then you really want to worry about that. And keep domain-specific behavior in one place. That will help you with your data management, whether you're using RDBMS or key value storage or S3 or what have you. And again, if you need to go change a behavior and you find yourself having to touch multiple services to do it, after you're done with that, or maybe even as part of it, you probably ought to ask yourself, should I be refactoring or thinking differently about the services here? And then what size should my services be? The smaller the service, the more benefit you get from decoupling, right? But you want to get them just right. And hat tip to Spinal Tap on the whole idea of how do we size things. And if you haven't seen Spinal Tap and you don't get the joke, go see the movie. It's awesome. You love it. But one rule of thumb that people generally talk about is that you should be able to write or rewrite or rewrite your service in a small number of weeks. I left small in quotes there because that definition can float a little bit. And then of course if you can't make a change to the service and deploy it without changing other things, then again you may have a little bit too much coupling there, and your service might need to shrink a little bit. But then at the same time, the smaller your services are in general, the more services you're going to have, the more moving parts you have, the more dependencies you need to track. And so you got to be ready for that, operationally when you're deploying for testing, deploying for production, those kinds of things. On the topic of environments and deployments, in general, not just for microservices, but just sort of a good housekeeping in general, is to keep your environments as close to production as you can, right? Using Docker or Chef or Puppet or all these sort of infrastructure provisioning type products. Keep a service running per host, right? You want to minimize the impact that one service can have on another service. You want to minimize the impact of a host outage, so you don't drop a whole bunch of services. Use VMs, obviously, or even better, containers from a resource utilization perspective. Containers and microservices are often talked about, in the same sentence or at least the same paragraph, because they have a lot of things in common when it comes to what their benefits are, and they reduce kind of the overhead of what you have to do. And immutable servers is another thing that people find kind of interesting and useful. This idea that I'm going to stand up a server and run it. It doesn't matter if it's a container or a VM or what have you, but after that's done, nobody logs into it after that. In fact, some customers I've talked to even have the path they take is once they've configured an instance, whether that's done manually or through Docker, Chef, Puppet, what have you, they throw away the credentials. They're never going to log into that system again. If it breaks, they're going to replace it, right? That is a pretty sneaky way to make sure that you don't have environment drift, because nobody can log into those things, which works pretty well. And then of course, PaaS solutions can also be helpful in this kind of scenario, but they can also constrain you, right? Because now you might be constrained to a particular ecosystem or a particular tool chain, and you give away a little bit of the flexibility that you get out of microservices. And kind of bottom line, automate everything. If you're doing manual deployments right now of your monolith, you're probably going to have a pretty difficult time doing manual deployments of your 50, 60, 70, 100 microservice application if you're doing that manually. So automate. And very quickly, I'm going to go through some of the things that you kind of want to look out for and kind of just come at this with open eyes. This isn't necessarily something that's easier to do, right? Things that are better to do aren't necessarily always easier. So keep that in mind. The services will evolve over time, right? You're going to split services, merge them, those kinds of things. Don't freak out about that. Just know that it's going to happen. Try to minimize it. But that's just a natural part of the evolution. You've got to be rigorous in handling failures now, because you are no longer making in-process calls to a library, right? You're making a call over the wire. What happens if the wire breaks? What happens if that service isn't there? What happens if it's overloaded? What happens if it throws errors? There's a lot of good libraries out there, like Hystrix, for example, from Netflix, that help you bake in circuit breakers and those kinds of behaviors so that you can fail fast. And then you definitely want to look at those kinds of things. Reporting will probably have to change, right? Because your data is probably going to change. You may not have the data in all the same places that you did before. I'm sorry about that. The Windows menu popped up on the machine there. The network is reliable, and all the other kind of H fallacies of distributed computing, understand those, right? You don't have infinite bandwidth between these services. You don't have zero latency across these things. So Google the 8 fallacies of network computing or distributed computing, understand and internalize those, because you're going to run into them when you're doing microservices. Be careful about how you expose your data over the wire, right? Because the consumer of that data will assume that anything you send in is fair game to mess with, and that might introduce extra coupling that you didn't intend. And then deal with dependencies gracefully, and if you rely on a particular service and a particular version of it, make sure that you test that. Make sure that your kind of integration testing of your pipelines account for that. Some of the best practices for the CD pipelines, you want to have an automated software pipeline, right? Ideally, you're going to have one platform that gives you a single pane of glass to this, right? And the reason I mention that is if you really go down the road of microservices and you're going to use different technologies for both developing and possibly hosting and deploying your different microservices, some with VMs, some with containers, some with RDMSs, some with key value store, those kinds of things. You don't want to lock yourself into a single automated software pipeline that only handles container deployments, right? Or only handles VM deployments, or only handles cloud deployments, right? You want to have one automated software pipeline that handles all of your software pipeline, and deployments, no matter what the what the intended target is for those deployments. Make sure you've got good test coverage. Make sure you keep in mind, the kind of the test pyramid. Lots of unit tests, less integration tests, few system tests. Automate your tests, and really automate them, right? Oftentimes, I find people claiming that their tests are automated if they can push a button to run the test, right? But what about all the stuff that you have to do before that? Standing up the instance that you're going to run the software on, standing up the infrastructure that's going to run the tests. All of those things need to be automated as well. Go for self-service automation. That's always good. ChatOps is interesting. It helps reduce your onboarding time, waiting complexity. Ideally, you're going to get a real-time view out of this system of all of your different pipelines and your releases and where your dependencies and exceptions are happening, and where your problems are going to show up. And make sure that this deployment pipeline plugs into monitoring, right? Because you want to be able to do, ideally, you want to be doing monitoring while you're still in development, right? You don't want the first time that you throw monitoring on your code to be when you go into production, right? What if monitoring causes problems? What if you're not catching the interesting things, right? Monitoring is sort of a feature in some ways, and yes, it's often run and provisioned and so on by a downstream team rather than an upstream team. But the more monitoring you could get into your pipeline, the earlier, the better. That's definitely something you want to think about. So, and some other, kind of more kind of development-oriented types of things. One repo per service is something that I've seen recommended quite often, so that you don't have kind of code pollution between the different things. Keep independent pipelines for each service. Automate everything. Make sure that your tools and environment agnostic in your pipelines, because if your software pipeline only supports Java development, then you're going to have to write all your services in Java, and you may or may not want to do that. And then, of course, test automation, service virtualization, those things are very important. Track all your artifacts through the pipeline, so where did this artifact come from, why was it produced, what are the changes in it. One of the nice things is, with automated software pipelines, is you can bake your compliance and security checking in, right? So for automating, for auditability, it's a really cool thing to be able to get that done. And then create reusable models for all these processes and automation for all of your various pipelines. So I took a lot of time to go through these things. Thanks for listening to that. I'm going to turn it over to Mark now, and he can dig into this a little bit deeper.
Hey, Anders, that's great. You covered a lot of ground. Really appreciate it. And one of the most succinct presentations on microservices I've ever seen. Amazing. Anyway, I'm Marc Hornbeek, and I'm trying to flip the slide. Doesn't seem to be cooperating. Huh. There we go. I work with Trace3. In case you don't know, Trace3 is an enterprise. We serve Fortune 500 IT organizations, consulting services, systems integration, and we partner with a lot of product companies as a value-added reseller as well. We have a variety of practices. DevOps is certainly one of those, and together with that, services and partners to support continuous delivery pipelines and microservices re-architecting as well. So fundamentally, I'm going to talk. I'm not going to go through the design and dev architecture point of view so much because Anders, I think, covered that really thoroughly. I'll speak kind of briefly more from a user's point of view and user's experience and maybe an ops experience point of view a little bit. I use a kind of a cute metaphor. All my slides have something to do with pasta just for fun. Partly because of my own experience, a lot of my background came out of the networking world, and I find a lot of parallels between network systems and microservices. I mean, to some extent, in a big picture sense, re-architecting applications for microservices has a lot of parallels to developing digital network systems. Some of the network systems I was involved in were very large monoliths, big digital telephone system, for example, that ended up being close to 23 million lines of spaghetti code before we decided to finally turn it more into a layered architecture. We actually had a project called Lasagna, which was to kind of turn the spaghetti into more closer to a service-oriented architecture. It wasn't microservices at that point, but it was leaning in that direction. Meanwhile, we had a totally separate packet switching system that was a lot closer to what today would be called microsystems. It was a lot of bounded applications loosely coupled through a standard protocol that you could, there were literally hundreds of applications, different protocols and different functions across the switch, all loosely coupled. But what's interesting is, the results, just looking at what happened with those two different types of systems, which I find today with microsystems, the world is sort of repeating that for applications. So if you looked at the big Monolith product, it was getting roughly 5 times less productivity compared to the loosely coupled bounded system, and something close to 8 times more defects being delivered to the field. And the overall release cadence was also significantly less. For the large system, it was measured in months, and for the one that was architected along the lines of microservices, the release cadence was measured in days. So clearly there was a major difference, and even though this was like an early example of something similar to what we're now calling microservices, it definitely is an example that bears out the value of microservices and a lot of the things Anders was saying. And Anders pointed a lot about to the underlying processes that have to support microservices, something that, with the large monolith, many of the things are somewhat handcrafted compared to much more automated when you're dealing with many parallel, loosely coupled autonomous systems, and that was true in these cases as well. So definitely, from my own experience at that, I would support many of the things Anders has said and other examples that I've dealt with in the field as a consultant at Trace3 and other places. Who's doing microservices? Lots of people are doing microservices. The idea started back in, to some extent, I guess, formally with some of the publications Martin Fowler had. He talked about this idea of strangler patterns, where you take a big monolith or a tree trunk and slowly strangle it by adding in separate little microservices, and eventually the trunk withers away, and you end up with these loosely coupled microservices instead. By the way, I couldn't find a good past analogy for the tree. I was thinking maybe spaghetti or something, but couldn't find a picture. Anyway, continuing on the theme of pasta, the Amazon coined the concept of two pizza teams. How big should a microservice be? Well, it should be about the size of whatever a team that could consume two pizzas would be. So that was one definition of how big a microservice would be. There have been some recent studies about who's doing microservices. The numbers don't quite match what we heard in the initial poll in this meeting, but what CB Insights published showed that a rapid increase in just the search words for microservices, building up a great deal in the past few years. And pretty much all the unicorns are claiming they're doing microservices, and that field is getting crowded as well. Technology companies that are valued $1 billion plus. There are several surveys. I'm quoting a couple of examples of results of surveys below that are saying that organizations that were at least participating in the surveys are saying 50% of the applications are being built and deployed with microservices in mind, and at least 30% of them already have some microservices in production, or at least another 20% piloting. The numbers may vary depending on what survey. Certainly the numbers on our poll here in this webinar didn't reflect that, but it's definitely on the upswing and here to stay. This is another good example, recent webinar and talk by Matt Rainey at Uber. I thought it was a really interesting talk. It's available on YouTube, but again, it was confirming that by applying microservices to Uber software, they were able to accomplish more than 1,700 microservices, and that led to unprecedented velocity, productivity, and the idea of being able to continuously deliver software for Uber as they added more and more engineers very quickly in a short period of time. Ironically, the result of that is you're kind of back to complexity. Maybe it's not the same kind of spaghetti at the code level, but at the system level, Matt talks about how it has led to the complexity of having to deal with literally thousands of microservices. So that's some indication of what's next beyond microservices, I guess. Many other organizations are still trying to get to this level, but certainly it confirms the trend. So what are some of the challenges? The ones that I see and are certainly reported a lot, you can kind of think of from a process or ops point of view, two dimensions to the challenges. If you have a lot of microservices, you're going to end up with multiple delivery pipelines from dev through to production. So there's challenges on the horizontal direction across those microservices. First of all, you have to have skills to stand up and operate pipelines, and those skills are a little different than just a big monolith, more of them at least. Not sure what I'm getting. Okay. And managing resources across many pipelines as well. And in general, re-engineering the product as you evolve from monoliths to microservices, as you strangle the tree, essentially. And then there's vertical challenges of dealing with, no matter how many pipelines there are, but it gets more complex as the number increase. How do you do an overall performance test of the product and re-engineer the processes as they become more and more of them, even though the intention is for all of these pipelines to be independent. In reality, if you do need to do a product re-engineering that changes the boundaries in some cases, which you would say it's not supposed to happen, but it can happen, then you may need to have more complex process re-engineering to go with the product re-engineering to match the changes in the product. And finally, release coordination. Overall, there's a lot of ops overhead together with its complexity, but as we've said, it does have value. It's just that these things need to be, these are the challenges that need to be taken care of. That's about all I was going to say for the moment. I think we're going to open the floor for questions, given the time that we have left. We'll go through some questions.
Exactly. Very good. Thank you, Mark, and thank you. I love the thematic slides, the pasta thing. Everyone in the room here is saying we're all sort of getting hungry, so that's great. Who's hungry for some microservices? We've got a few questions from the audience. The first one, Ravish asked early on in this seminar. He talked about how are microservices different from just a set of web services that are deployed and run independently. Mark, do you want to handle that one?
Sure. I mean, fundamentally, if you think of service-oriented architectures and microservices and web services are kind of typically considered a form of service-oriented architectures, microservices are very similar, just a finer granularity. I think that is the simplest way to answer that question. It's a matter of granularity is the dominant reason they're different.
Okay. Anders, anything?
Yeah, and
I
think
the. Okay, great.
Yeah, I mean, I agree. I mean, I think the the history is always just a little bit different. I mean, I think also people or a lot of people at least kind of had a little bit of a bad taste after SOA turned into sort of a vendor war. Use my platform, no, use my platform, and so it became a little bit less about choosing the right technology for the job as opposed to choose my technology. And I think microservices are, at least to me, appear to be a little bit more of a grassroots kind of a thing. Much more of a the individual contributors in the world saying, hey, this is a better way to do things, as opposed to the vendors saying, hey, you use my SOA platform to solve your problems. But SOA and the vendor thing are really sort of separate, and I agree with what Mark said very much.
Excellent. Okay. This is a very interesting question about relational databases from Mehul. What are the practices for common monolith application relational databases to make it better support microservices? What do you need to do to those? If I'm understanding it correctly, what do you have to do to your database to make sure it supports microservices?
I can take that or
okay,
Mark, maybe you go first.
You can go.
Okay.
Go ahead.
So I think the thing that you run into kind of very quickly is let's say that you have two tables and there's a foreign key from one table to the other. Now if you end up with one service owning one table, quote unquote owning, and another service owning the other table, now you have to who owns that foreign key and how do you deal with it? I mean, that's just sort of a very kind of simple example. And so you kind of end up with you have to think about how your data model is structured to make sure that you don't have, because coupling in the data model may very well translate into coupling between services, right? Or even requiring you to have the coupled data in a single service as opposed to being able to split it across multiple ones. Reference by value instead of foreign keys, if that's something that you can do, so that and at all costs, I would say, well, maybe not all costs, but at lots of costs, avoid things like multi-phase commits and transaction coordinators and those things, unless there's a really, really, really good reason why you need it. And honestly, maybe you don't need an RDBMS, right? I mean, if you're doing a chat forum, and the latest chat pops up a millisecond later, or something like that, that's not a big deal. That isn't necessarily something we cry about. Or my Facebook feed is a little bit out of order or something like that. Nobody's going to care about that. If it's not if it's not withdrawing money out of my bank account, maybe it doesn't need to be an RDBMS. So you can think about things in that way, because those things can be the non-RDBMS solutions can be easier to scale and easier to shard and do all the things that you want to do with it after that. Mark, you probably have stuff to add to that.
Yeah, certainly, I agree with what you said. Actually, I would refer people to Sam Newman's book, The Building Microservices. It has a lot of information about how to deal with this problem. But like you said, sharding databases, there's a lot of techniques. Part of it is building isolation layers as you're trying to separate data dependencies between microservices. So I tend to get more concerned about the transition from a big RDB that has many interdependencies between services to the point where you end up with separate microservices that are independent. So that transition is part of the challenge in how you build in transition layers in order to get there.
Awesome. Okay, very good. So we've got a lot of great questions coming in, so I want to keep moving through them. Where's that one from David? I thought that was interesting. Do you think it's possible to go directly in production with a microservice architecture if the team already knows well the domain, or should we always come from a monolith and then do the transition? Mark, why don't you start on this one?
It's not the traditional approach. I think most folks do start with a monolith approach just to try to get experience with their own product and the use cases and what is important. That's really critical in order to break up product into microservices. You really need to know where the boundaries are, what makes sense. And unless you have an excellent view to start with of what the user experience will be, it's dangerous to start that way. It is possible, technically, of course, but it's not the recommended approach. If you do just happen to have an excellent view of that partitioning, I guess there's nothing wrong with it. You just need to be very confident that you're not going to have to backstep and re-architect the system, because that's very disruptive, not only from a product point of view, but all the processes that you put in place to manage microservice pipelines.
Thanks, Mark. Anders?
Couldn't have said it better myself.
All right, very good. So we have a question from Robert. You didn't use the terms quote-unquote enterprise architecture and quote-unquote enterprise data. In fact, I don't think you mentioned enterprise anything, but these are critical for large organizations and not necessarily just legacy. I repeatedly asked the question, but I can't get a satisfactory answer on how microservices support enterprise data and enterprise architecture. Either of you care to comment on that?
Well, enterprise architecture.
Well,
go ahead, Andy.
Go ahead, Mark.
No, Mark, please go ahead.
I was only going to say, maybe the answer is you're not getting the answer because of the question. Enterprise architecture are we talking about an enterprise application or all applications across an enterprise? Because you pretty much, at the enterprise level, there are a lot of things involved in architecting all of the services involved in an enterprise, but typically they're a federated set of systems, both data and applications. So I think everything Anders already said addresses that question from an application point of view. From an overall total set of applications for an enterprise, I don't think anybody's really tackled that. And microservices per se doesn't directly address it, but maybe I'm misunderstanding the question. Anders, do you have a different view?
No, I think I'm pretty much, kind of in the same boat there. That unless there's some, kind of formal or rigorous definition of enterprise architecture that I'm sort of not aware of. But, I don't want to reduce it all to, hey, it's just code. And certainly in an enterprise or, in a large organization with lots of stakeholders, a particular kind of culture, certain, quote unquote legacy apps. I sort of dislike the use of the word legacy because I find that a lot of people use it to mean code I didn't write. As soon as it's somebody else's code, it becomes legacy. And when in fact it's, it might very well be just because it's already existing doesn't mean it's crap, doesn't mean it's old, doesn't mean it's bad. It's just there, it's existing. You got to deal with it somehow. But if it's difficult to kind of culturally approach the kinds of things that you need to do well, say get better at kind of DevOps methodologies in terms of rapid deployment and continuous delivery and those kinds of things. If they're more challenging in a particular organization, it can be a little bit more difficult to steer the ship or that in a large organization. And so certainly there are maybe not unique complications in larger enterprises, with respect to data and architecture and those things. But the technical aspects of the problem, I don't believe are really fundamentally different.
All right, very good. Still lots of questions out there. The next ones are from Paul. Is there a best practice or prescription that would help an architect approach a monolith to assess its viability of being turned into a microservices or decomposed into a microservices application? And how do you go about convincing a service-oriented architecture-aware or rich shop that a container is a better way of delivering that functionality? Anders, let's start with you this time.
In terms of prescriptions for decomposing large monoliths, I recommend a Valium the size of a hockey puck. That's probably the best place to start. But in all seriousness, I mean, I think so I'll take the last part first, right? Containers. Why are they cool in this arena? And I think there's a couple of things. One is, at some point your CIO or your CFO is going to knock on your door and say, hey, I heard about containers. I heard that they can save us money because I don't have to have the overhead of a VM and an OS for each process that I want to run. And that sounds like that's going to save me money, and I'm the CFO and I care about that. So be prepared to have the answer to that question for no other reason. I think a lot of the things about containers that are cool are, kind of intersect very well with microservices. For example, if you have microservices, you're probably going to have a bunch of them. If it takes you a long time to stand up a service, that means it's going to take you a long time to do deployments, right? Whether that's for production deployments or a deployment that I'm doing while I'm testing as a developer or QA or what have you. Microservices running in containers start up a lot faster than an OS and a VM, right? So speed can help you there. You can also, if you're, and I've experienced this myself, on my laptop, right? I'm out in the field working with a customer. I got to fire up a large complex application, a clustered application. If I do it with VMs, I can only run so many of them before my laptop runs out of juice. If I use containers, I can run more because I don't have the overhead of the OS for each one of them. So I probably spent more on containers there than on the other part of the question. But so I'll let Mark kind of comment on that and take the other one.
Okay. Yeah. I mean, I heard two parts of the question. One was that is there an assessment approach to determine whether or not a large monolith or legacy app should be re-architected into microservices? So, yeah, I mean, there are. I'm not aware of a formal, standard assessment, but there are lots of consultants out there that do have assessment methodologies, including Trace3, to help determine, what's the best approach for partitioning a monolith or a legacy product into microservices. But it starts with, what are your business goals? What are you trying to accomplish? And then you can determine, what are you trying to break out to do what. But fundamentally, it's typically just to get speed without losing stability, and without scaring the pants off the ops people while you're at it.
Exactly.
Yeah.
Exactly.
The second part of the question is, as far as containers is concerned, I think Anders answered it well. I would just add an interesting word. I wouldn't claim to have invented it. Sam Newman, again, is a reference I like. Before containers and microservices, a lot of the pipelines are automated. We talk about automation. We talk about orchestration, which are somewhat prescriptive. But as you get deeper and deeper in more and more microservices, it becomes more of a choreography. So actually, that's a word that Sam used in relation to the architecture. But as Anders was pointing out, it's not just the product architecture you need to worry about. It's the companion processes. So I would also say that approach and word applies to the processes as well. And containers are ideal for that, to support a choreography of processes as you have a larger and larger set of somewhat autonomous applications going through a pipeline. Keep in mind, it's not just the product artifacts that need to be containerized, but also the process artifacts that go with it. The tests, the data, being able to revert quickly without going back too far in the process, and all of those things. I think containers are really suitable for that. Without some form of containerized, artifacts as well as product, it's hard to implement that at speed in a choreographed manner.
Yeah.
I hope that helps.
Awesome. Yes, Mark, thank you very much. So we are heading at the top of the hour right here. There's a ton more questions The information, I've got the resources up on the page here. All the slides, a video of this webinar will all be made available to folks after this. There's one last question I'm going to sort of throw us, have us leave on, and that question comes from really two people. Annabelle asks, as the number of microservices goes up, are there products or best practices to help enumerate, classify them, or discover what's out there? And Bhaskar asked, what are some of the tools available to deploy or monitor those microservices? So, Anders, do you want to talk a little bit about electric flow and the things that we do to help people coordinate those releases and track them into production?
I don't know. I can't hear Anders.
Yeah, I can't hear Anders either. So I guess I will pretend like I'm Anders and just say we absolutely have a product that will help you deploy into whatever sort of workload execution venue you'd like, whether that's Kubernetes or Google Container Engine or Amazon Container Service. We'll deploy into any of those for you. We know what's been deployed, the version and the microservice sort of definition, whether that's an artifact that comes out of Docker repository or our own internal repository, and then we can tell you exactly what's running and where. So from a dependency management perspective, you're always going to be covered and you're always going to have those endpoints available for people to use. So
couldn't have said it better myself, especially on mute.
All right, wonderful. Thank you. Yes, you were sounding very quiet, which was not like you. So I'm going to pass it back to Charlene. Charlene, thank you for letting us join Mark. I want to thank you especially for joining us from Trace3. If people are out there and you have some questions, reach out to Mark or Anders, and we'd be happy to work together to help you guys get on your way towards microservices.
Okay, great. Well, it just leaves me to thank Mark, Anders, and Sam for being our panelists today in this webinar. So thank you all, and please be sure to check the devops.com website for upcoming webinars. And thank you all for joining today. Have a great day.